Good afternoon, everyone. Thank you for joining Mega Asia webinar. I'm Chris from Mega Hong Kong. Sorry, there's a little bit delays due to some technical issues. And today our topic is be safe, test your breakers with Mega Balto. We are happy to have Mr. Tinku Halim, who is the Balto product manager, to present the webinar in live. So you automatically muted during the webinar to prevent any background noises. During the webinar, if you have any questions, please type in the question box, which you can see on the left of your screen. We answer your questions in the Q&A session. At the end of the webinar, please have us fill the survey, which is on the right-hand side. We'll be sending the presentation materials to those committed the survey. Attendees will be able to download an attendance certificate after they have finished the webinar and completed the survey. And recording of this webinar will be available in 2 days' time by email. So without further delay, let's start now. Thank you for joining us today.
Okay, good afternoon, everybody. I hope you can all hear me. Thank you very much for joining me today. My name is Tinku Halim, and I am a product manager for Balto, which is our protection test equipment. So today I'll be presenting a topic which is be safe, test your breakers with Mega Balto. What I would like to cover today is to go through why testing is important. We'll then cover some of the international standards that specify testing procedures, and then we'll go on to some of the features of Balto and the benefits of the actual test equipment that we provide within Mega. Okay, so let's have a look at why testing is important. So testing is important because ultimately what we're trying to do when we test our DC high-speed circuit breakers, we're trying to get some predictable performance. We need to understand and be confident that the test equipment is actually calibrating and making sure that the DC high-speed circuit breaker is operating to specification. Some of the questions we typically ask is, do you know how your protection scheme will perform in a fault condition? Do you, for example, test it regularly? If you've never tested it, how do you know how it will behave? It's all about predicting performance and being confident that it will react accordingly under a fault condition. So that's a very important point with all of the testing that we do. Some customers don't do any regular testing. They take more of a disaster recovery plan than actually a prevention plan. And obviously the penalty we have with any sort of failure in the DC network with the REL system is the downtime. So there are penalties and costs involved in that. So that's another reason why testing is important. And also, the cost of any unexpected outage. These all play a part in encouraging people to test regularly, make sure that everything is performing and working as predicted. And ultimately, it's a gamble that won't pay off. The disaster recovery plan works with some companies, but typically the prevention plan is far more predictable and gives you the confidence that you will maintain the network that you're running and that everything will work as you plan. And obviously nothing is maintenance free. The DC high-speed circuit breaker is a mechanical and electrical device. So over a period of time, it does degrade in performance and it needs regular maintenance and checking to make sure that it's still operating to specification. Some of the main manufacturers for DC high-speed circuit breakers actually have a maintenance procedure in their user manual. So two examples I have here. The first one is from a manufacturer called PAL. So PAL, in their maintenance service schedule, actually recommend that the breaker and the tripping mechanism is checked after 5,000 mechanical operations, or at least once every 4 years. And that's to make sure that there's a check that the actual DC high-speed circuit breaker is operating correctly. Another main OEM manufacturer for DC high-speed circuit breakers, which is Secheron. So Secheron is the global leader for DC high-speed circuit breakers, and in their maintenance procedure, they specify that a detailed inspection is performed every 18 to 24 months, and that is to check to see that the overload current protection is working correctly, as well as other parameters as well. But that's the main purpose for a DC high-speed circuit breaker, is to make sure that it's tripping according to the current that's been set for that particular asset. So really, the main thing here is that if you test your DC high-speed circuit breakers and you test your protection relay, it gives you predictable performance, and it gives you the confidence that your protection scheme is working as expected and to specification. Okay, so testing is also important. We're seeing increasing demand globally for rail passengers. We're seeing increasing passenger numbers. I have a graph here that I can share with you. So we have a number of regions throughout the world where we're seeing passenger numbers gradually increasing, but in particular, Asia Pacific is by far the highest number of passengers actually using the railway networks. And you can see from 2012 up to 2019, in Asia Pacific, there's been a considerable increase in traffic. Obviously in 2020, when the pandemic hit, the number of rail passengers decreased. But as we are now coming out of the recovery from coronavirus, with again starting to see increasing passenger numbers. So with increasing demand on your DC network, there's increasing demand on the protection scheme that's also protecting that DC network. We're also seeing expansion in the metro system and growth as well. This can be through line upgrades and new lines. So as more and more passengers demand the railway network performance, the operators then have to upgrade the lines. They have to then introduce new lines to cope with that increase in passenger numbers. And here you can see a metro system graph that shows how the metro system has grown over the years. Obviously, it goes back quite a way back to 1860, but if you look up towards the latter years, so from 2000 up to 2017, you can see almost an exponential growth in the number of metro systems expansion and also growth, and that is particularly dominant in Asia Pacific. What's also causing this? So there's also increasing traffic on the lines to cope with the increasing demand with rail passengers. That also has an effect on the protection scheme that you have. So you then need to make sure that your protection scheme works accordingly to the increasing demand on that particular line. That may be a case of recalibrating some of your protection devices, and also to make sure that you have the correct protection in place for that increase in current demand on the lines. So we have the power generated in the substation now, because there's an excessive amount of power generation to cope with the increasing passenger demand. That also adds pressure to your grid network, but it also adds pressure to your protection scheme from your relay all the way down to your circuit breakers. So that's another very important reason to continue to test your protection scheme, to make sure that it's working to specification with the increasing demand on your DC network. Okay, so those are some of the main points we've covered with why we need to test, but when do we actually need to test? So during commissioning, so if you're introducing new assets into your DC network, you need to make sure that they operate as predicted and to specification. And for any line upgrades, so as we've mentioned before, as we increase the current demand on lines by upgrading to cope with the increasing number of trains that are running on those lines, we need to make sure that that upgrade the protection scheme that's supporting that upgrade is also capable of coping with that additional increase. And obviously, once everything is running and to specification, we need to make sure that we regularly test that protection scheme, because a lot of the infrastructure is mechanical and electrical and needs to be tested to specification periodically to make sure that it's still working to specification. And obviously, if any assets are taken out for repair or refurbishment, before they're put back into online duty, they also need to be tested to see that they're still performing to specification. Okay, so in summary, testing is important. What we're trying to do here is to keep passengers, keep workers safe, and that is because of any sort of health and safety issues. We're trying to avoid any health and safety issues because of the failure of the protection scheme. The other thing we're trying to do is to avoid service downtime, because there could be penalties with the disruption to service. Trains standing still costs money, so we're trying to prevent disruption to service. We're trying to prevent any health and safety issues. And ultimately, we want to prevent any sort of catastrophic failures that may occur if your protection scheme doesn't operate as expected. And that in turn can affect a lot of your other assets within your DC network, potential destruction of other assets. So it's very important that you're confident and that the protection scheme that you have is working to specification, and that you have the confidence. It's almost like an insurance policy. Okay, so that's the main reason of why we need to do testing when we do the testing. There are also international standards that specify routine maintenance for DC high-speed circuit breakers, and that's what I'll cover in the next section. So this is under the IEC, which is the international standard. So we have two standards. The first one I'll talk about is for traction power substation. This is 61992. And this is an extract from 61992 that talks about a maintenance procedure for your overcurrent relays or releases. Okay, so primary current injection is actually defined as a routine maintenance test in IEC 61992. It already exists in the standard. So the international committee is suggesting customers should test their overcurrent releases. And there you can see it there in the section there. Check that the current in the circuit breaker causes the opening. So it's specifically stated to actually test that. The other test that IEC 61992 specifies is to test your contact resistance. So on your circuit breaker, you need to make sure that the contact resistance is within a specification, whether it's the manufacturer's specification, to make sure that no excessive heat or any other issues are caused as a result of high contact resistance. The other important specification in IE 61992 is the actual rate at which we apply the current in the primary current injection test. And 61992 also states that this shall not exceed 200 amps per second. So in other words, when we actually apply the current, we need to slow the rate of current injection so that we can ensure that we get an accurate trip current level for your circuit breaker. That's a very important part for the actual testing procedure. So we're testing the overcurrent releases, we're testing the contact resistance, and we're also making sure that we don't exceed the 200 amps per second for current injection. And the same also applies to the other IEC standard. Now this is for rolling stock, so this is IEC 60077. And again, 60077 also states calibration of releases as a defined routine maintenance test. So this is your primary current injection test. Okay, so a check shall be made that the current causing a trip operation of the circuit breaker is within tolerance. So that is the check. Also, IEC 60077 also stipulates testing the main contact resistance. again, to make sure that there's no excessive resistance that may generate excessive heat. And also 60077 also talks about the rate of rise shall be less than 200 amps per second. So this applies to both rolling stock, and as we've seen in the previous example, it applies to your traction power substation DC high-speed circuit breakers. So it exists in both areas within the railway infrastructure, and it's defined as a routine test. So in summary, okay, so IEC stipulates the primary current injection and the contact resistance for traction power and rolling stocks are defined as routine tests. And it also explicitly states that the current is less than or shall not exceed 200 amps per second for the actual rate of rise. And that is to make sure that we don't increase the current too quickly, because if you increase it too quickly, you then potentially actually miss the point at which the breaker trips, because you're injecting the current at a rate at which it cannot react quickly enough to actually turn the current off. Okay, so that's the standard. So we've covered why we need to test. We've covered the standards that state the need for testing your current releases through primary current injection. And Mega is compliant. The Balto is compliant to the 200 amps per second. It's one of the few products on the market that allows you to actually slow the current down to 200 amps per second. And it does that through a combination of batteries and ultracapacitors. Because once you get to a high current, 6,000, 8,000 amps, and then you need to slow the slope down to 200 amps per second, there's a lot of energy that's needed to maintain that high current with that low rate of rise. But the Mega Balto is compliant with that. So as you can see here in the graph, this is a typical graph we get with the Mega Balto. So between T0 and T1, you can see the high current injection. And then from T1 all the way up to T2, we then slow the rate of rise so that we make sure that we correctly get the correct trip current, which is the IDS, which is the current for direct setting, which is your trip current. Okay, so that's what the standards specify. Now, if we have a quick look at the Balto and the features and the benefits, because often we talk a lot about specification and what the product can do, but how does that feature relate to benefits to the customer? Okay, let's have a quick overview of the actual Balto. So Balto comes in two forms. There's a Balto modular. So the modular, we have 13 models, all complete systems. So you buy a complete system, fully operational. The main difference between all of the models is the amount of current that you require in order to test your DC high-speed circuit breakers. So it's modular in design. You can choose to go from 4,000 amps all the way up to 40,000 amps, depending on what your requirements are. Okay, but every Balto modular performs a number of standard tests. The first one and the most important one is to actually do the trip current test. So it determines the DC high-speed circuit breaker trip current. The second one that it does, it actually measures the circuit breaker opening time. So you can see how quickly your DC high-speed circuit breaker opens. And also we measure the contact resistance. So these are some of the main tests that are also specified in the IEC 61992 and IEC 60077. We also have a shunt mode. So if you have a thermal breaker or a molded case circuit breaker that has a thermal trip, you can apply the shunt mode, which is a constant current test that can also output high current over a longer period of time to test the thermal trip on a molded case circuit breaker. So those are the main primary current injection tests. Balto also has a secondary current injection. This is where you're testing your protection relay. So this is an optional extra. Not all customers necessarily want to test the protection relay, but it's there, it's available, and you can actually test your secondary current injection. And typically what Balto does, it simulates the output of your shunt into the relay. So you can actually output low voltage to simulate the actual output of the shunt for live line conditions. As I said, the Balta modular comes as a complete system, so you'll get your 2-meter standard cable set. We do have other cable sets for extension. These are accessories. And as we've said in previously, Balta modular is compliant to both 61992 and 60077 for the 200 amps per second reduced rate of rise for the current. Okay, so that's modular. So if you have the data sheet, you can see on there exactly what each of the systems that we offer, each of the systems actually offer. So with the Balta modular, you can extend your original purchase. So if you buy a 4,000 amp system or an 8,000 amp system, depending on the trolley that you buy with that, you can then extend it for your future requirements with additional current generators. As you can see in the picture to your left, you can see where you've got up to 5 current generators. Each one of these current generators outputs 4,000 amps. So you can easily extend your Balta modular to suit your future needs. And in the data sheet, you can also see exactly what each system contains. It's very clearly stated in terms of the capability of it, but also what's included with each of the complete systems. The other Balta that we have in the product range is the compact. So the modular, as we said previously, goes up to 40,000 amps. The compact is fixed at 4,000 amps. And this is typically used for rolling stock applications where the current required to test the breakers in a rolling stock are far lower than the traction power substation. The compact, however, does exactly the same types of tests that the modular does. It does the trip current, it does the opening time for your circuit breaker, it does the contact resistance, and it also does the shunt mode for your thermal breaker applications. But the output current is fixed at 4,000 amps and cannot be extended beyond 4,000 amps, unlike the modular, which can be extended. Again, like the modular, the compact will also do your secondary current injection, so you can test your relays. And again, it comes with the standard 2-meter cable set and the 1-meter extension, which is an optional accessory. But just to be clear, the functionality of the compact is 100% identical to the modular. The main difference here is that it's fixed at 4,000 amps. And again, that's really for rolling stock applications. But it's applicable for both standards because of the 200 amps per second current rising slope that both the modular and the compact support. Okay, so those are the features of the Balta modular and the compact. How are these advantages? So if we look at the first one, so the primary test really for both modular and compact is to test your IDS, which is your trip current direct setting. D is direct, S is setting. And the advantage here is that it's all about safety. You know, if you can guarantee that your circuit breakers operate to specification, then you can have the confidence that they will operate to the safe level that you have set them to. The benefit here is obviously we're protecting passengers, we're protecting personnel that work on the railways, and if your protection scheme works correctly, you're then protecting everything that it's protecting. So all of your infrastructure in your substation, all of your infrastructure in the rolling stock as well, is protecting all of those valuable assets further up the chain. The other feature for Balta is testing the opening time. So obviously, DC high-speed circuit breaker is a mechanical and an electrical operation, but any mechanical device is subjected to wear and tear, and over the period of time that it's in service, and this could be up to 40 or 50 years, you know, it'll start to degrade, it'll start to get residue and buildup of various elements in its lifetime. So we need to make sure that we can be confident that the opening time is maintained throughout its life cycle. And we do this by testing the opening time. So we can guarantee against poor maintenance and any wear and tear that occurs throughout its life. So the benefit is that we understand the behavior of the breakers, and we're confident that they will work to specification, and we do this through a scheduled maintenance program. We're also testing the contact resistance. So we're detecting any high resistance which could lead to potentially heat generation. We want to make sure that in its operating life, that the actual contacts of the breaker aren't causing any high resistance, which could then lead to a potential failure in the future. And finally, the other benefit for Balto is the ability to test your protection relay. Here we can ensure that we can actually set the correct parameters on your relay to make sure that it's working to specification. But also, the important thing here is that when we test the relay, we're testing the entire system as well. We're testing the relay, we're testing any current sensors, we're testing all of the connections, and we're testing the DC high-speed circuit breaker. So it's testing the entire protection scheme with the Mega Balto. So obviously the benefit for doing that is we're verifying the proper functioning of the protection relay, but also the entire protection scheme. And it's all about safety, it's all about reliability, and it's all about maintaining performance. So there we go. Those are the overall benefits: improve safety, minimize downtimes, because a lot of the railway network operators are subjected to penalties if there's any downtime. And also we're maintaining network performance by regularly testing and making sure that everything is operating as expected. And that is it. That's basically what the Balto does. It makes sure that you're given the confidence that your protection scheme is working to specification. So I'll take any questions now if I can.
All right. Thank you, Tinku, for your presentation. So now it comes to a Q&A session. If you have any questions, you may type into the chat box. Tinku will answer your questions. And for those of you who are leaving, please help us fill in the survey, which is on the right-hand side of your screen. We will send the presentation materials to those with the survey. And again, also, there will be an attendance certificate. You can download it at the bottom control panel, which is the icon on the right-hand side. And also, the recording of this webinar will be available in 2 days' time by email. So we'll spend about a couple of minutes for any questions.
So each module, the actual weight is specified in the data sheet, and the current generators are a single man lift. So that's around 20 kilograms. The compact is slightly higher, but I can get that information for you from the data sheet.
Okay, thank you, Tinku. And I guess we don't have any further questions. If any more questions, feel free to send an email to megahongkong@mega.com. And you can also go to our website, mega.com/webinars for any future webinars. And just a reminder, we're having another webinar next Thursday in the morning at 10 o'clock morning time. Topic is transformer testing basic. So if you are available, I will encourage you to join. You can go to our website, www.mega.com/webinars to sign up for the webinars. So thank you again for attending. Thank you, Tinku and Sumiti as a panelist. We hope to see you again next time. Thank you, everyone. Bye-bye. Thank you, everyone, and bye-bye.
Thank you, everyone. Thank you, Grace. Bye-bye.
Okay, well, thank you very much for joining me. If there's any questions that you need to ask after the presentation, please get in touch and we can help you with any questions you have. And also, we can also arrange a demonstration for you should you require one. Okay, thank you very much for listening. Thank you.